Okay, so this is question 2, continuing on with the, let me just go back to the front page here. GCSE Combined Science Synergy, 2018, Paper 1, Life and Environmental Sciences. Oops. So question 2 is a physics question. To do with the specific heat capacity. So you can see here a metal block, and this has been heated with a power supply, and then the temperature is recorded. And what they want to know is, well, they start with a graph. The student measured the temperature of the metal block every 60 seconds, and then table 2 shows the student's results. 2.1, complete the graph from the data from table 2 on figure 3, which is the bit of graph paper below. Choose a suitable scale for the x-axis, label the x-axis, plot student's result, and draw a line of best fit. Okay, so you want to go with something simple, but it needs to cover a good portion of this graph. Let's enlarge a little bit. You don't want a little tiny scale, but you want to make it suitable. Let's go for a different colour, I think. Nice on there. So I'm thinking here, just go up in minutes, I think. 60, 120, and it makes it easier to plot then. 180, 240, and that labelled axis is time in seconds. Okay, so we've got 60 seconds, 24.5, so that's 24, that's 25, so that's 24.5 is there. At 0 we got 20. Next, 120, 29. Apologies if this is very simple, I just quickly draw it. 180 is 31, which put us here. Okay, start the curve now. And 240 puts us at 31.5, which is around about there. Draw a line of best fit, something like this. Okay, so done. Should be 4 easy marks. Okay, questions on this then? Didn't want to do that, did not want to do that. Are these, beginning with these? Okay, so a rate of change. Any rate is something over time. Of temperature of the block is given by the gradient of the graph. Determine the gradient of the graph over the first 60 seconds. Okay. Rate of change on a graph is the gradient as determined by the change in y, vertical axis, divided by the change in x, the horizontal axis. And in this case, we have temperature changing with time. Temperature in degrees C, time in seconds. If you look at the graph, over the first 60 seconds. It's pretty much a straight line, so they've made it quite easy for you. So this is this bit of data here. Which is 24, sorry about that, it's not very straight line. 24.5. Although be careful, because we got 20, so we got the change in y. This delta symbol means change. The change in y is 24.5 minus 20, because we're starting at 20. So looking to catch out there. You think starts with 0? No, it does not. So it's 4.5 over 60 seconds. I'll write it over here. Divided by 60. Quick calculation. That's that one. Next is the metal block had a mass of 1.5 grams. The specific heat capacity of the metal was 900 joules per kilogram per degrees Celsius. Calculate the change in thermal energy of the metal during 240 seconds. Use the physics equation sheet. Give your answer in kilojoules. Okay. Just make you aware, if you're not, this is kilo and this is joules. So 1 kilojoule equals 1,000 joules. They want the answer in kilojoules. Right, the equation for this is qu2. That's how you remember it in, that's my cat, Carl. That's how you remember it in A-level chemistry, but, you know, GCSE, you've got the equation sheet. Okay, so Q is no, Q. Q, that's our energy. What's it saying? How does it express it here? It says calculate the change in thermal energy. That's our energy, which should be thermal energy here, because it relates to the change in the heat of the block. M is mass in grams. C is our specific heat capacity, which they give you here. They give you the units. That's that one. And oops, delta T is the change in temperature, and that is in degrees C. So, or degrees Kelvin, but degrees C. So the change in temperature over 240 seconds, go back to the graph, here, is equal to 31.5, sorry about that, minus what it was at the start, which is 20, which gives us, if my maths does not fail me, 11.5 degrees Celsius. Okay, so we've got some information now in order to calculate this. The mass of, the mass of the block, I give you here. Okay, but we want this in grams. So 1,000 grams in a kilogram, so times this by 1,000, so you'd have 1,500 times your specific heat capacity. I would suggest putting that straight into kilojoules, okay? If you put that straight into kilojoules, that's going to give you your energy in kilojoules. You could do it after doing the calculation. That's the last bit of the calculation, but do it at the beginning, I think. Okay, if 1 kilojoule is equal to 1,000 joules, then 900 joules is equal to 0.9 kilojoules. Times 0.9, change our change of temp times our change of temperature, 11.5. Just double check. 11.5. Okay. Plug that into your calculator. Let's have a quick look at that. Times that. 15.5 kilojoules. Boom. There's your answer. Okay, I hope that's clear. Just look on the equation sheet and take it from there. One last bit here. So it says another student repeated the investigation. Give 2 variables the student would need to control to be able to compare the results with table 2. To make them comparable, you're looking to keep certain variables the same. Okay, so in a repeat of the experiment, you're going to keep all sorts of things the same. So this could be the current supplied to heater, greater the current, greater the energy, the greater the heating effect. So you're going to keep that the same. And well, the material, I think, same metal block. There are others, all sorts of things here. Let's just have a quick look what they've got. Bear with me. Let's see. Can't actually see the number on that. Is that it? So there's a whole bunch of stuff here potentially you can have. Hopefully you got mine on there. Quick look. Mass of the block, size, dimension, yeah, same block, current, power, thickness of insulation, time interval, starting temperature, blah, blah, blah. Right, okay. Great, hope that's helpful. My cat's getting in the way, so I'm signing off. Any questions, let me know.